Assalamualaikum warahmatullahi wabarakatuh. So now let's continue the examples of your BJT DC analysis. Okay, so we have 3 examples here. The first one is what you need to calculate here is your IB, IC and IE. You are given alpha equals 0.99. So what is the relation between alpha and beta? So the derivation is in the previous video where beta is the common emitter current gain. So alpha equal beta over beta plus 1. So beta must be more than 1, let's say 50, 100. But alpha must be almost equal to 1. So that's why you see the value here 0.99. So the first step, when you see the circuit like this, you need to complete the whole circuit. Okay, so first of all, what you need to do is you need to complete the whole loop. So in order to complete the loop, so this is 4 volt. So what you need to do now, you change this one to plus minus. You write here 4 and connect the ground together. And again, your 10 here become plus minus. Here to ground, and then this one become 10. Okay. So next, what you need to do, you are going to have the loop at the BE loop. So this is what we call BE loop. Another loop at your CE. So what will be the equation at your BE loop? BE loop. So we become, starting from here, so we become minus 4 plus, there will be no resistance at your base, but in between B to E is actually your 0.7. So we become plus 0.7 plus REIE, that is 3.3K multiplied by your IE. So this one will be equal to 0. So directly you can get your IE value. Okay. And then after you get your IE value, what you need to do next? You need to find at your CE loop. So what will be the equation at your CE loop is starting from here. You need to be counterclockwise. Here must be clockwise. So become minus 10 plus RCIC plus, here we have a voltage drop, VCE plus REIE equal to 0. Okay. You know your RC, how you can find IC from IE? Using the alpha. So what will be the formula? Formula to relate IC and IE is actually IC equal alpha IE. IE you already know from your BE loop just now. Alpha is given 0.99, then you can get your IC. So do you know already your IE, so you can get your VCE, one equation. So let's see the answer. So this is your BE loop. How you can get your IC from your IC equal alpha IE. This one is from this formula, IE equal IB plus IC. So you can get your IB. And the last one, you can get your VCE from the CE loop. Okay, so this is the second example of BJT DC analysis where you need to plot what we call here output load lines. So when saying output load lines, directly start from your CE loop. So your CE loop here is minus 12 plus RCIC plus VCE plus REIE equal to 0. Okay. So from here where you need to plot the output load line. So we're taking the output load line is this is the graph of IC and VCE. So this is the line. So your line is equal Y equal MX plus C. So your Y is actually your IC equal MVCE plus C. Okay, so the first step that you need to do is to have the CE loop. So your CE loop will consist of IERE because the circuit previously having resistance at the IE. So next step, you need to change the IE to IC over lambda because you know IC equal alpha IE. So your IE will be equal IC divided by lambda. So once you change this one, rearrange the equation until you got the equation of equal Y equal MX plus C. Okay. So from this equation, we can find the intersection of A and then intersection of B. So let's say first we are going to find the B intersection where you're going to make your IC equal to 0. So when plug in equation number 1, so when IC equal to 0, your VC equal to 12. So that's why you get 12 here. So how you can get the point A? So point A means your VCE will be equal to 0. So you can get your IC 1.01 equal to 12. So your IC equal to 12 milliampere. So that's where we can get here 12 milliampere or 11.9 milliampere. So once you have this intersection of A and B, you need to find the Q point, where is the intersection between the IV characteristic and the load line. So let's say this is the IV characteristic. So how we can know if the IV is 75.1? So this is where you are going to find the loop at the KVL at your BE loop. So from here you can get your IV. So what will be the equation? Minus 6 plus RBIB plus BBE plus REIE will be equal to 0. So just then from this equation you can get your IB because your BBE is given. Your RB you already know. IB you don't know, right? How you can relate IE into IB? So what is the equation? IE equal IB plus IC, right? But you know your IC is actually IB plus beta IB. That is 1 plus beta IB. So just replace this into here where you can get like this equation, and then you can calculate your IB. So let's say this is the graph of your IB. So what is the IB value? Is this one. Then you're going to draw the load line. So the Q point here is the intersection between this load line and the IB characteristic. So you're going to have the value of around 5.63 and VCE is equal to 6.31. So how you can get this value? After you know your IB is 75.1, you just need to plug in this equation, and this is the load at the this equation. Okay, so that is how you find your load line output load line. So the question says just now, plot the output load line. So this is what we call output load line. Okay, how just now how you calculate the IB is from this loop, and then you can get 75.1 milliampere. Okay, so let's move to the third question. So this is what we call common base circuit because your base will be connected to the input and to the output. First of all, when you have this circuit of common base, you are going to modify the circuit to become the one that you always see. So change the position of your BJT to become VC and E. So let's see from your base is connected to your RB and then to the ground. How about your emitter connected to your RE and you have with your VEE and ground, and your C connected to RC and then to ground. So what you need to do next is just loop, do like usual. So this is what we call BE loop, and then the one we call CE loop, and then do your loop directly, and then you can find your answer. Okay. Same with here, change this circuit to the normal position where your base will be connected to ground. This is your base, this is your emitter, this is your collector. Your collector will connect to 5K and then to your 15 volt. Your emitter will connect to 10K and your VEE negative supply. So first step, change this to the normal position. And what will be the equation of your BE loop? Voltage between B to E is 0.7 plus REIE minus 5, and at your CE loop is let's say starting from VCC, so become minus 15 plus RCIC plus VCE, so we have VCE here plus REIE minus 5. So then you can get your IE and your VCE. Okay, so that's all for the example for your BJT analysis. Try your best to redo again all the examples and complete the assignment 3 inside the Google Classroom. Assalamualaikum.